thought I'd do a little follow-up on this solar panel angle considerations with a graphic here that kind of tells the story that might make it easier for people to understand. So here we are near the spring equinox, and what happens there is the sun all over the world, regardless of your location, the sun's going to come up due east and it's going to set due west. As it's rising up at solar noon, the angle that it will be above your location will be equal to your latitude. And you'll have essentially a 12-hour day. 12 hours of sunlight, 12 hours of night. If you compare that to the winter, the sun comes up south of east, is shallower in the sky, and at the winter solstice, December 21st, it'll be about 23.5 degrees down, which is the tilt angle of the Earth, below your latitude. And at sunset, the sun will go down south of west in many locations. And if you look, the number of hours that the sun is up in the wintertime is much shorter. Now if we compare that to what's going to happen this summer, and that's what we're setting up for now, see the sun can come up north, much more north of east, will end up much higher in the sky, and at the summer solstice it will be up to 23.5 degrees above your normal latitude, and then will set much more north of west. Now if I take a look at my example here with Minnesota, our sun on the summer solstice will rise at 55 degrees, which is to the east-northeast. Travel through the sky, and it'll set at 3:05, so much more north of west. And the problem is, if you have a set of fixed solar panels facing due south like you should, and maybe set up at your normal latitude or maybe a little higher for your summer setting, that the panel still will not be exposed to the sun for many hours. Matter of fact, it'll be probably be around 7 a.m. before the angle of the sun is such that the panels will be exposed to light. And the same thing happens on the other part of the day. More like at 14 hours in is where the sun will stop shining on the panel, and you get to due west and you won't get any on the panel. So that's a good reason to consider some strategy to be able to take advantage of the sun as it's on the west side as well as, or on the east side as well as on the west side, by either having staggered panels or some kind of tracker setup. Now if I look at the monocrystalline solar panel power curve that I drew the other day, which is this is the kind of performance you'll get out of a standard monocrystalline, polycrystalline kind of solar panel, where it'll, at solar noon facing south, will get 100% of its available power, and then either side of that will get less power. And you can tell I put it on these 1 hour hash marks. Since the Earth rotates at 15 degrees per hour, you can see 1 hour before noon what percent of the power would be available, 2 hours before noon, how much power you'll get out. And you can use this chart to get an estimate of either how much power you should be getting with an ideally placed solar panel, or a set of panels that are not exactly aligned with where the sun is, because this also works east and west as well as north and south. The panel doesn't really care. The other thing I've added on here is I added some hash marks where you can determine at the 4 hour point how much power you can get out. In this case, no matter where you have this panel, if it's pointing right towards the sun, you can get 4 hours worth only at above 83% available power. Looking at a 6-hour perspective, you'll get up to 63% of the available power. So you can tell that solar panels only have a certain range that they can capture a lot of the sun power. They're not ideal. Anyway, I'll put a version of this as a graphic in the description area, and you can download it for your purposes. It's a good handy tool to use to determine if the kind of power that you're getting out of your panels is what you expect, because what might be happening is there's nothing wrong with your system other than your panel may not be pointing exactly towards where the sun is in the sky on the day you're doing your measurements. So I wanted to put this chart together for myself. I can also use it to show other people, tell them about how a solar panel works, and you're welcome to use it for your own purposes. So have a good day.